Well, hi, good morning, and thank you so much for joining me in my shop. Today is, what is today? Today is April 8th, and would you believe I woke up to snow on the ground? Can you believe it? It's April. Snow on the ground. Very cold. It's -8 outside, which is very cold for April weather. And the last video I posted was a short one about the ice storm that went through here. Just comment that we're happy in our house now with electricity and heat and all that, but there's still something like 60,000 people out of power in Ontario. And I'm guessing most of those would be rural now, and an awful lot of the system, like there's an awful lot of distribution system for very few customers in a rural area, so probably an awful lot of work just to get a handful of people back on. So unfortunately that's continuing. I feel so sorry for those people because we went 9 days without power here. The first 4 days we also had no internet, even on our phones. Even though our phones were working essentially because they're tied to the cell system, we still had no internet here for 4 days. So can you imagine what that's like? No power, no internet. It's pretty boring. That's what it is. Okay, let's get focused on the radio here. So, just wiping some of the dust off. So the last thing I did, as I remember it, was conclude that some signal tracing might be a good idea here. And so what I'm talking about doing then is I'm going to feed in a known signal into the antenna of the radio, and then I'm going to use a signal tracing device, which is basically another radio. It's this thing here, to listen to the signal as it works its way through the radio, starting at the antenna, and then we'll see how far through the radio we can get before the signal disappears. And I'm liable to be quite clumsy at this because so we're going to want to feed the signal not in through this loop. This loop was connected to my signal generator. We're going to want to just connect this right to the antenna and blast it in. Okay, can you remember? Ground and antenna. Okay, speaker's connected there. Antenna's connected to the signal generator. We'll switch that on. Yes, speaker has popped out the back here. Yeah, the way they've done the speaker connection, the original speaker connection here is pins. What are my cats doing? I don't know if you hear all that noise in the background. That's cats. So this is an original, a real McCoy old speaker, and you see it comes with these kinds of connectors, which would then slide into the back here. What someone else has done previous to me is they've taken 2 nails, soldered wires to them, and then that's the that's the feed into here to reach the output transformer over this way here. So those gray wires feeding the output from here to this output transformer. The thing about the speaker output here is that it almost certainly has B+ on it. It's really looking for the kind of speaker I just showed you, that horn speaker with the plate on the piece on the bottom. That's a high impedance thing, and the B+ current goes right through the speaker. We can't let that happen with a regular speaker, so use an output transformer which is just barely in there, which you could say is an impedance matching device. You could call it that. to match the low impedance of a modern speaker to the high impedance needs of this. Output transformers or audio transformers tend to mess the sound up a fair bit, so they're not the best thing to use, but it is what it is. Okay, I'm muttering now. Signal generator. So the signal generator is set to 850. Any reason why I wouldn't want to start there? 850 would be mostly closed. So 100%, I guess this is, you could think of this as the percentage of how closed the capacitor is. 100% closed, and on the 0 it should be 100% open. Wait a minute, I didn't. No, it should be 0%. 0% closed. 100% closed. How closed is it? So to be at the low end of the band, I'm going to guess 75 here to start. And we're going to try right away to pick that signal up with the radio as it is. Probably won't succeed. Now, you know what? I'm in trouble here. What can I do with this inside the radio? Like inside the cabinet? So my signal generator is quite sensitive, or signal generator, my signal tracer is quite sensitive. It has this is the ground, it has this large probe with multiple wires coming up to it, but only one thing coming out. So what's inside here is a vacuum tube, and the grid of it is out here. This just goes right to the grid of the tube that's inside here. This gets a little warm after a while of using it. So amplification takes place right here, right in here. That makes the impedance of this connection extremely high because it's just going to a grid on a tube, so it's pretty much an open piece of wire. So this affects circuits minimally, and that's not 100% without affecting them, but fairly minimally. If I hold this in an electric field that's strong enough, just holding it in the field, we'll hear it come out of the speaker on this guy. So maybe, and it's a bit of a long shot here, maybe I can just hold this up against these coils that are in the radio, and without actually making electric contact, just get it close enough to know the signal is there, and also to peak it up, work my way through the radio that way. Only way to know if that'll work is to try it out, and I have some doubts about it. Let's take a look at the schematic and just see how the very front end of this radio is done here. There's a very nicely drawn schematic here. So we see the antenna comes in. There is a 3-pole switch selecting where in this coil you feed the antenna signal in. Then it is tuned. This would be the first tuning knob right here. So we can actually do this without even turning the radio on. We can try this. It might just be too weak straight from the signal generator. After the first tube, it might be a little stronger, and this would be the first coil, and then there's another one, and then here we're talking about audio transformers. See, they have an iron core in them. So these are the audio transformers. Let's give it a go. Just reading some notes here. Drawn by W3NLB. Eh, 1st of March 2004. 20 years ago somebody did this. Great, okay. I'm going to take a little break and then we're going to attempt this. Okay, let's get the signal tracer going here. So this guy hums a little bit. I think that's kind of normal, maybe normal for it. This is not a typical, this is a radio, but it's not a typical radio. This is a TRF radio, the same as this old one here, which means it has no local oscillator, no converter in it, no intermediate frequency stages at all. It's just straight from the antenna through amplifiers, detector, and then out the speaker. There's a speaker in here. This thing will work in a couple of different ways. You can switch it to listen to audio. That's not, or you can switch it to RF. That's where it's set now, RF. When it's on RF, there's two bands. There's band A and band B. One is the broadcast band, and the other one is a range of frequencies that most local oscillators are within. So we have a volume control, which is controlling basically the speaker volume, and this is the input control. Kind of has a volume sort of effect on it. That's the deal. How sensitive is it? So we're turning this up. Just holding it close to my hand. So see, it will be affected just by things being close. So my plan, I'm not sure this is going to work, is to simply dip this near the coils that are in the radio here. We'll see what happens. That's kind of all I can do. As for the ground, I should probably connect the ground to the chassis of the radio. Probably would be a good idea. But I don't think I can do that. Okay. I'm not sure. Yeah, I don't know. I'm just going to leave this hanging because I don't know what else to do with it. Stick it over there. Okay. It's time to start up the radio. I'm going to need to, well, no, I don't need to do that. I was going to say I'm going to need to see the tube heaters. Maybe I will. I can probably do this. Let's see them. Plugged in. Power supply is ready. Over here. Just checking everything out. Okay. First time in nine days I've done something in here. Here we go. So we'll be feeding the power through the dim bulbs here. See this one start up glowing, so we know we're so far we got something happening. Let's just check the make sure the speaker's connected. Okay, I can see the heater in here, so we know we're heating up. Volume is controlled with these two controls here. This is basically controlling how much current reaches the heater. This control for these two tubes, and this control for these. I think all three of these. Yeah, you can see it go up and down. Okay, you can see the heaters in here. Okay, now coming out of my signal generator is a, let's just double check out. I want the strongest signal I can get out of here. Let's just put that like that. This is up full, this is up full. We got lots of juice coming out of this thing. It's way out of calibration. It's way beyond its normal calibrated amount. So, and we've got 30% modulation, 1000 hertz tone. That's what we should hear. I'm not hearing a thing. So, 847 is the frequency we're transmitting to the radio. Everybody be just real quiet. I can't imagine I'm going to hear something doing this. This is the 3 settings for the antenna. Did I? Yes, I did. Did I hook up the antenna? Yes. Okay, so we'll start by trying to detect the 847 hertz on the tracer. We'll just hold it in the vicinity here and tune this. So we'll make sure we're on B. We'll tune it. I hear it. It's not tuning very sharp, is it? It's kind of funny. Why would that be? This should just tune it in around here. 8. Why are you doing this? Yeah. Okay, let's just keep going. I won't worry about the... just put it on the list of anomalies here. It's as if the frequency is double. Picking up a harmonic. So I'm transmitting 840, but I'm picking up on here 16 something. Why not 8? Why not down here? Maybe the lower frequency isn't only the harmonic is detectable this way. Okay, we'll try tuning this. See what happens. I'll hold this still. About there. Go to the next coil. Nobody home. Okay, we'll turn it up. I can hear it. Well, that's interesting. Just that setting. Okay, this will be the detector now. Just so you can see what I'm doing with the probe, I'm just laying it up against the coil. These dials, they don't match at all. Okay, now, is this being amplified? I'm going to fool with the rheostat here. Coming through loud and clear. Doesn't matter where you set this. So it can't be this one. Shouldn't be. Okay, so it could be the signal's doing this apart from the radio itself. I could turn the radio off and we'd get exactly the same thing. Let's find out. I'll just cut the power here. Radio's dead. I've still got exactly the same result. Whoa. Oh, it's because I've turned it up over here. My signal tracer. What are we finding out here? Where did it go? Oh, I don't have it on now, and I can't pick it up here. It's this coil that's really strong. Okay, so this one's gone. Let's turn the set back on. Turn it up a bit here. Okay. Okay, what we'll do is there's a very strong station at, there's a French station at 860. Why don't we tune the radio to 860? Then we'll try to pick up the real station. Not much of a peak here with this. I'm jamming a whopper of a signal into the antenna of this radio. If it's having trouble with this, that's kind of like a fat chance it's going to pick up any radio signal. So let's give it a try. Okay, I have to go make sure my antenna is switched on properly down into the shop here. My outdoor antenna. We'll stop for a moment. Okay, so I'm going to turn off the signal tracer because it has a hum. Get rid of that. This guy is operating. The speaker's right here. Let me stick my ear in it. Yeah, there's a hum in there. It's doing something. Okay, we're going to switch to the outdoor antenna now. And again, fat chance on this working. I would be just totally floored. Now, let's make sure this is correct here. Yes, it is. Okay. Does anybody hear anything? Of course not. Okay, stuck that speaker right on my ear. Not a thing. Not a thing. Well, all I can do is just twiddle these knobs a bit, but I have to put this on my ear. Absolutely nothing. Okay, I don't think I need to spend more time on that. Radio doesn't work. That's my conclusion. Hey, it doesn't work. Okay. To go further, I've got to take it out of its cabinet again. And why did I put it back in? Can anybody answer that question? I'll take it out of its cabinet and we'll just do a more careful look at the signal entering the radio and moving through it. Okay. Okay. If you hear a lot of crashing sounds in the background, that's my cats. They've got the zoomies. They're just going wild back there. Okay. Let's just look physically at how the antenna connection is done. Oh, I'm going to take it this way. Okay, it's fairly stable. Oh, it's not stable enough. Let me yeah, let's just leave it like that. So let's see. So I have the antenna. Interesting, they cross the wires right away. I wonder why. Why wouldn't they? Anyway, let me just make absolutely sure now. This one is the outside one. That's the antenna. This is the antenna connection. So we're coming here, we're coming through up to, well, it looks like it's connected to the rheostat here. No, it's connected to that three-pole switch. You can see 3 wires coming up, probably from the 3-pole switch. It's attached to different taps up here on this coil. You can see tape on it here. This is friction tape, or hockey tape as we call it in Canada. This stuff could have been put on a long time ago, a long time ago, before the regular vinyl tape was around. This is actually better tape, frankly, because look, it's still there. And you do that with vinyl tape, and 15 years later it's dried up and unwound itself. Friction tape's very hard to get off, though. So why did somebody do this friction tape here? Because I'm going to guess they made connections under here. There's tape on this wire too. It's connected down here, so it almost looks like this coil has been either replaced, removed, worked on, and put back. It looks like that. I'm not saying that's the case. So the signal on the schematic, I believe, it just comes up through here, picks one of the 3 taps, and then passes through this coil down to the bottom end, which is almost certainly this other wire here, which is really does give the idea that this has been replaced or it's been removed and fiddled with. My close-up camera, there's some unusual stuff to look at here. I think the automatic focus is on the camera, so this might present a bit of a problem. I wanted to look right in here. And maybe the automatic focus is not on. Okay, so I'm going to deal with the focus on this camera here. Just, in fact, I'm going to leave it running here. Oh, the automatic focus is on, but we don't really want that to be the case. So just bear with me a moment here. I'm just calling up the. What happened? Okay, hang on a sec here. Okay, let's carry on now. So what I wanted to look at is up here. These are the 3 tap wires, if you like. Look at the other end of the coil. So what I think is unusual about what I'm seeing here is the you see the wire. There's a wire coming in attached to the terminal, then there's this other wire. What's this other wire doing there? And I gotta point to it so you know for sure what I'm talking about here. The wire I'm talking about is obvious. It's this one. Wouldn't this terminal? Well, I would expect this wire to be attached to this terminal inside the coil where you can't see it. But it's outside. It doesn't look like it just doesn't look right. It's possible. Maybe somebody shortened this up. Maybe they found a break in the wire and they shortened it by taking a turn or 2 off. That's what's coming out here now. The coil looks fine. So, you know, these radios, they are susceptible to lightning because the outdoor antenna is connected to them, and it's pretty much connected right to this kind of coil. I thought I saw a wire wound resistor in there. Wow. I look at this with my eyes. I don't even see those wires. Ooh, careful, don't do that. Those look... There might be some kind of damage right up in here. Ooh, man, these are really, really... Don't touch them, man. Right in there. Doesn't look good. Oh, it's broken. It is broken. Right there. Okay, so why did they use a wire wound resistor here? Because they had no alternatives. They had no higher wattage resistors that they could use. That's my impression. This is not a coil. I don't think there's any intention of it being a coil. So this would explain an awful lot right here. Yes, it would. Let's just double check and make absolutely sure that I think, yeah, I'm sure that is, yeah, you can see the end of the wire right there. So it's not likely I can repair that. You know, I could pull a couple turns off and kind of twist them together and whip some solder. Maybe I could. It looks like there might be a bit of a problem right up in this area too. Anywhere you see some rust, like right up in, ooh, these wires are so fine. So is that the connection? They just slammed this rivet down on the wire? The other end? How do they do the other end? 2 rivets. Oh, I see a piece of wire sticking out there too. What's that? That doesn't look good. Not looking good. But the thing is, it's easy to replace this with a proper resistor, with a modern resistor. I don't see why it wouldn't work. Okay, let's look at the schematic and see if we can find where that is on the schematic. So there's a resistor right here. Wire wound resistor here. Is anybody telling me what the resistance is of these things? Huh. Is there, maybe there's another one that's intact, like maybe this one. Oh, this says 2 megohms right there. But why don't you tell me about this one? Grid resistor, 600? Is that 600 ohms? That could be, that could be 600 ohms because it's a piece of wire there. Generally, a resistor there, jeepers, stop oscillations. I'm not sure why there would be a resistor there, but 600 ohms, eh? So we could just slam in a 600 ohm resistor across the defective one and see what happens. Because if this is open, which it certainly appears to be open, then there's no antenna connected to this radio at any time. There's never been. Now, why would looks like it's open because of corrosion? You can't really get a bolt of lightning through here. The bolt of lightning would go down through the coil and would burn the coil. Not likely to burn this. I think it's just corrosion that's done this guy in. Okay, that's good. 600 ohms, eh? Let's give it a try. Hey, what did you just take there? Hey, what'd you take? Oh my gosh. Grab this. I wanted to chew in on a chunk of lead there, cat. Okay, so I have the resistor in. And we're going to try this radio again. Isn't that right? Isn't that right, Bert? Actually, Bert is the short form of his name. His full name is Filbert. Filbert like the nut. Okay. You're really looking for trouble, aren't you? No answer comes the reply. Okay, so we're going to hook up the antenna here. Check the speakers. Lost its connection now. There. Okay, you know what? Let me get this set up, and then we'll go at it here. Okay, ready for a test here. So we'll turn down the rheostats in case the volume is blaring, which I kind of doubt. There we go. We're in business already. Yep, tube's heated. Okay, speaker on. Yes, there's a faint hum in the speaker. That's because I've turned this down. So we'll turn this guy up. More hum. Yep, louder hum. The voltage we're operating with 99 volts on the power supply. Okay, we'll turn this one up. Come on, something. Hard to say if that's a radio or not. Okay, anything. Listening for any sounds coming out of the speaker. Any clicks, pops, anything. This is right up, this is right up. Nothing. Okay, so long shot doing this from an antenna. We'll do is we'll use the signal generator again. The signal generator can put out a signal easily 10 times what the antenna can put out, and that's a strong antenna because that's an active antenna, outdoor active antenna. A little amplifier. So, okay, now I think we have this tuned to that frequency. This guy is putting out all it's worth. Hear it now, hear it now. Okay, here we go. Okay, so what I'm going to do, I'm going to stick a microphone right on there. This is, and see if you can't hear it. Not much to hear yet. Just make sure this is rolling off at some point. Okay, now put on my own headphones here. Okay. The other microphone, so we'll go up on this one, down on the other. So the only microphone you're listening to is this one here, and you're listening to the speaker hum. So if anything comes out of this speaker, you're going to hear it. Okay, talking about that. I swing the frequency back and forth on this a little bit. I think I left this tuned to that, but let's put it on 1,000 here. So you should hear a 1,000 hertz tone come out of that speaker. Sure. Okay, we'll tune this around a little bit. Didn't hear a thing. 860. What I should do probably is use the signal tracer again and see if anything's different this time. Good idea. Turn it on. And I'm using the signal tracer with the ground wire disconnected, which is a little bit weird. It's just laying here on the bench. Now you can hear every little. Ooh. Okay, trying to separate out all these sounds. We don't want to listen to this now, so I'm going to move this microphone. Hopefully you can hear me. I'm not even sure you can hear me. So I'm going to put this microphone now over near. Hey, where's that tone coming from? Oh, how do you like that? Okay, so this is really putting out a signal now. Turn this guy down. Okay, I'll do something with this microphone. I'm going to do a dumb thing with it. I'm going to put it back. That's going to be confusing. Put it here. Just because I got to put it somewhere. Hold still. There we go. Okay. It is a radio receiver. So we're operating at 860. But I got this dialed up at 16 again. Nothing at 8. Something very strange going on, because this doesn't make sense to me. We're on RF. We're on band B. Band B is this band. We're definitely tuned to 16. So we seem to be picking up. How do I know for sure it's the signal generator I'm hearing? Well, what else is producing a 1,000 hertz tone in here? It's got to be. Oh my gosh. what's happening here is I don't know how to tune these old radios. Let's turn this down one notch. Still hear it? Sure. Okay, so I got headphones on now. If sound starts coming out of here, I won't really recognize it. Let's tune. What's happening here? Things got a little quiet down in this area. Ooh. What's going on there? There's a recorder going by. So I think that. So once you cross this stage, the RF is done and it's audio going beyond. What happens? Coming and going. So I'm making no electrical contact with this. I'm just holding it in proximity to this coil. Nothing. Back here. Sounds like some intermodulation distortion to me. Oh, 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 oh. Why did I make that much noise? Wow. Okay, let's set this up for 860. It seems to get louder and quieter suddenly. We're at 500. That's a crazy frequency anyway. Let's go 590. 590, there's a strong station. Go 590. 590. Okay. Don't understand why it doesn't pick it up down where it should. How come? I think you're really close to the lead coming from the signal generator. Right on the signal generator lead. I don't get it. My signal generator is set to 590, dial 590, hear nothing. Always hearing it up here. Okay, it's the loose switch, the loose knob problem. It's not on B. Now it's on B. Oh, for crying out loud. Okay, let's get back to what we're doing here now. So now we'll dial it to 590. Oh, things are normal now. Oh my gosh, what a dumb situation I've been in. Okay, there we are. Tune this baby. Ooh, that's nice. Anywhere else? No. Okay, next one. Tune this puppy. Ooh, much sharper. Intermodulation that. But that could be the signal tracer itself. Next guy. Come on. Anything. Doesn't seem to have any effect at all. They just get close to this tube and they get the signal. Well, it looks like we're good up to here. Okay, let's put it back on the outdoor antenna. Did we get anything out of here? Did we get anything out of the speaker? Okay, so I'm going to move this on top of the speaker again. can we hear anything of this tone? Let me put this back up here. Okay, so you don't want to hear that. So make sure it's not audible. If we hear anything here, it's coming. Oops. Oh my gosh, look at this white powder all over everything here. Anything that was below my bench level has got a film of powder on it from my fire extinguisher accident. Okay, we should hear it right now. We don't hear it. Should have done this before. Signal level is not as high as I can put it. Tuning this one. Make sure these are up. I think you're supposed to turn these for best sound, not necessarily highest volume. Oh, I got losing control here. Calm down. Calm down. Calm. Nothing. So if we back this down a bit, I can't imagine that's going to help. I believe this one is affecting the heater on the detector. I have some trouble believing this would help, but so we seem to be good up to here. Speaker, please. Put this back here. At some point, I'm going to drop this microphone. So if you're wearing headphones, careful. The tone you're hearing is the signal tracer. It's good to there. Again, no effect here. Okay, so we got through the front part of the radio. Can we actually, can I hook this up to an antenna, have the front end boost the antenna signal, and pick it up with this, and hear it? That'll be my last experiment. So we're tuned to 590, which is good. So the first thing I'm going to do is I'm going to get rid of this guy here. And then we're going to switch microphones here before we have a disaster. Okay, still hear me? Yes, you can. Okay, good. This one's off now. Take the antenna and connect it to the antenna. Okay. So, listening with this.
If I had to give the tournament a grade, I'd give it a B+.
I'm going to tune in 590 here.
For reasons that I honestly don't even
I think this is
believe in
590.
that deeply, but yeah, the first round, there were a lot
Sports
of
channel.
blowouts.
Let's just wait a sec.
And there was really only the one notable buzzer beater before the Final Four, which again wasn't a buzzer.
That's definitely a
buzzer
sports
beater, but
channel.
it was a huge comeback late.
Question is now, we're picking it up in here.
Kind of a very simple. So if you're coming down and have a possession game, on the final position, carries a lot. But early, yeah, there was a lot of this is even the games that kind of were that close. I thought it was awesome. No Cinderella story.
No difference. Okay, I think that really proves the situation now. We're good through the first two stages. We get to the detector and something goes wrong. And it could be anything. So that's how far we got today. Tomorrow I'll carry on with examining the detector circuit and maybe there's a defect in the coil again, something similar happened, and we can track it down. There really isn't much to these old radios. Not many parts, not much to it, really. Okay, well, thanks a lot for watching, and I hope you have a enjoyable day. I have to, what am I doing? Going to the grocery store. I gotta shovel my driveway. There's snow out there. Did I mention that? There's snow on the ground outside now. And it's April. I don't get it. Okay, well, once again, thanks a lot for watching, and we'll see what happens tomorrow. Ciao.